Rational functions are things that are like fractions, only we're going to be looking at ones that have polynomials, top and bottom. As with any fractions, the bottom of the fraction cannot be a zero. Now, we need to be able to look at rational functions and decide where would the bottom be zero. And it's just a matter of extracting the bottom and setting it equal to 0 and then solving for x. And so the domain would be all the numbers except for that. We write that in different forms. Practice with this one. All the numbers except for what makes x plus 7 a 0. And so negative 7 is the only number that will not work. Now x squared minus 9 is a quadratic. To find out where x squared minus 9 is 0, we use our quadratic formula. We can use the program on our calculator. But there are two numbers that do not work for this one. So the domain would be all numbers except for those two. And we say that in other ways. Same thing with this one. X minus 2 cannot be 0. So it means x cannot be a 2. And I wanted to show you for this particular calculation or this particular function, another way of writing this function would be to factor the top, cancel the x minus 2's. So x squared minus 4 divided by x minus 2 is the same thing as x plus 2 except for one number. X plus 2 has a dot at 2, but x squared minus 4 divided by x minus 2 does not have a dot there. Now that is illustrated on graphs with a circle instead of a dot where the line is. Now we'll take a look at some of the graphs. The term asymptote refers to this particular situation. At x equals 2, there is no answer, but you notice as the graph gets closer to 2 on the left and on the right, the answers get larger on the right, smaller on the left. There is a magical line at x equals 2 called an asymptote. Now that is not part of the graph. It's just a line that signifies that there's nothing on the graph at that spot. This function has asymptotes at both 3 and negative 3. Now I won't go through the graphing of this by hand. You can type it into your calculator if you type it properly and see that the graph is going to look like this. Again, I have constructed the blue lines to indicate that those are asymptotes. There is no answer there, and the graph goes up and down along the asymptote. It just doesn't touch it. Now for this one, we want to look at another type of situation called a horizontal asymptote. There is a horizontal line that we could put somewhere on this graph so that the graph on the left and the graph on the right level off along that line. And this is where the line would be for this graph. Now I want to show you how to find that line. Here's the three situations that we encounter. Either the degree of the top and the bottom are the same. Look at this. The first one has a degree 1 on top, degree 1 on bottom. The degree is the same we divide the coefficients of those two terms. 2 divided by 1 would be 2. In the second one, 3x squared on top is a degree 2. 3x squared on x squared on bottom is degree 2. We divide coefficients. 3 divided by 1 is 3. Third one, x cubed on top, 2x cubed on bottom. We divide the 1 and the 2. However, if the degree of the top is smaller than the degree of the bottom, in the one on the left, the degree of the top is 0. There is no exponent. The degree of the bottom is 1. If the degree of the top is smaller than the degree of the bottom, the answer is always y equals 0. In the second one, degree of the top is 1, degree of the bottom is 2. So y equals 0 is the horizontal asymptote. In the third one, degree of the top is 2, degree of the bottom is 3. So the degree of the top is smaller, and it's a 0. Third and last situation, if the degree of the top is larger, then there is no asymptote. In the first one, that is 3x to the 1 on top, there are no x's on bottom, so it's a 0 degree, and so the degree of the top is larger than the degree of the bottom. Second one, the degree of the top is 2, degree of the bottom is 1. Third one, degree of the top is 3, degree of the bottom is 2. No horizontal asymptote.